Welcome, dear colleagues, to this EUCNC2020 Virtual session. I'm Gino Carrozzo, Deputy Head of Research and Development at Nextworks, an Italian SME, and also 5G Zoro Technical Manager. Today, I will talk to you about AI-driven zero-touch operations, security, and trust in multi-operator 5G networks, proposing you a conceptual architecture, which we elaborated in the work that you find in the proceedings of this conference. Before we enter into the details of the proposition, I'd like to briefly introduce a bit of background for our research, which started from the consideration that 5G networks today are not yet at a mature stage. Still limited scale in deployments, eMBB services, so mobile broadband available in production, not even low latency and massive type of communications. But more importantly, for the orchestration part, the network slicing is not fully chained with network monitoring and analytics, and so we cannot optimize the way slices are planned and operated during their lifetime. And network slices and services generally span a single operator domain. In terms of review of the state of the art, what we observe today is that the various layers of the 5G networks spanning from the access to the core DC part are typically operated by a number of controllers and orchestrators, as you see depicted here, with on top an end-to-end service orchestration layer, which is typically the part exposed to the verticals for implementing their services. And there are experiences in doing intent-based APIs for this service orchestration in order to reduce the complexity of orchestrating the bottom part of this picture. There are experiences of spanning multiple type of technologies, but still single domain oriented. And the focus for most of the projects in 5GPP phase 3, at least the first part of the phase 3, is on profiling the performances of the 5G in order to understand how the KPIs can be improved for the new services in the various vertical sectors, industry, automotive, media, etc. But in this scenario, what we feel is a near-term scenario that is not fully addressed by the current research is a scenario like depicted in this picture, where we have three operators acting in three different areas, having different technologies and different geographical span. As you can see here, the three operators have different type of resources. Some have only edge and core resources and cover only a given area. Others cover all the technologies, but in another area. And the problem is to try to set up something that can be really spanning into the different three areas. So operator A can be able to deploy its own services also in area 2 and in area 3. This is not fully addressed in state of the art. And this is the rationale behind elaborating the architectural proposal I'm going to show now. In order to do that, however, we may need to focus on some enablers and challenges to be addressed. First, what is still missing in order to realize this vision is the sharing of heterogeneous type of resources across multiple operators and different resource providers. And in order to do that, we need to go beyond the single operator. We need to announce the resources to the others and elaborate a way to establish multi-party agreements in order to reuse third-party resources and decrease consequently the CapEx and OpEx of networks, which instead should be estimated and overbuilt. And so the idea is to make it possible, for example, to allow the reuse of micro data centers in the smart cities, for example, available in street cabinets or at lamppost, and integrate them with the workloads and resources of a network operator willing to expand in that area. Another element is the effective coexistence of cloud native and traditional infrastructure as a service network functions. NFV version 1.0 was mostly focused and relying on virtual machines. Today, we mostly talk about containers, so mostly for the workload parts of the NFV realization. And containers need to be orchestrated together with the VMs. And still, state-of-the-art solutions are not fully covering the need for establishing seamless services, chaining services across the different elements of this composite network, from the bare metal servers to the VMs to the containers in a single mesh of services which can really implement the intercommunications required. Another element which is missing is automation. We are not anymore talking about tens of VNFs and cloud native functions. We are talking about thousands of them, and we cannot rely on manual intervention to make all the orchestration activities happen, which is typically what the different elements offer today. And similarly, we may need to go beyond the traditional bilateral business-to-business models for operators who want to establish a 5G service. It is to be a multi-party service model where we do not talk anymore of telco with towerco or telco with telco or MNO with MNBO one-to-one, but we talk more about multi-party distributed models where resources are chained from different areas, different providers with security and trust. And so an ecosystem which is enlarged with multiple operators, telcos, vertical slice owners, spectrum-only owners, passive and active edge facility owners, resource owners of various kinds, wholesale fiber owners, etc. In order to realize this vision, we need to rely on some building blocks. One of them is operational data lakes. Those are logically centralized reservoirs of operational data, where we can store resource monitoring data, traffic captures, topology information, performance metrics, all accessible via APIs. And the aim of a data lake is to allow data accessing, processing, aggregation, filtering. So to have a single point where logically we can take all this information, even when they rely on different parties, different operators. And on top of the data lake, or inside the data lake, we aim to plug in artificial intelligence engines, which can transform the network orchestration process into a cognitive process and allow the network to self-adapt and self-react to conditions which can change because of time, and also can allow to reduce the manual intervention needed. Another enabler for the multi-party story of the vision can be distributed ledger technologies. In particular, those could be used to implement distributed security and trust across the multiple parties and implement service chains across domains. And obviously, as I mentioned before, we need to have a cloud-native technology integration into this overall framework in order to be able to make the SDN-LV-based orchestration capable of doing coexistence of CNF and VNF and allow and take the benefit of the flexibility, scalability, and resilience that CNFs typically offer more than the traditional VMs. So based on that, the inspiring concept we had in 5G Zoro was to develop this architecture for zero-touch security and trust, allowing and ubiquitous computing and connectivity in 5G networks, which, related to the example we started with, can allow zero-touch resource discovery from the different domains, step 1 in this picture, then can allow intelligent third-party resource selection. This is the step 2, where we can pick different point of presence in different domains and consequently be able, third element, to establish trust among the different elements, establish the service chains end-to-end, and consequently run in a pervasive mode from one area, from one scope of operations into the others. So based on this, the architecture we proposed is an architecture as depicted in this picture. We have a physical layer as described before. On top of this, there is the 5G Zoro platform, which is this gray box here, which is split on top of the virtualization and abstraction layer into a single domain layer or per domain layer and the inter-domain layer. The different actions for orchestrating slices and resources and services, monitoring and doing analytics, establishing security and trust, as well as pushing resources and managing resources and spectrum, are split in these two layers, per domain and interdomain. And this platform interacts through distributed ledgers infrastructures with other similar platforms instantiated at other operators, and interacts with an operational data lake where the data for the AI-driven decisions are stored in order to offer a number of new services, what we call enhanced or evolved services for the 5G, where we have smart contracts, resource discovery and brokering logic, intelligent resource selection, spectrum sharing, VNF licensing, and secure SLA monitoring. The design principle of this architecture are service-based. It is a service-based architecture inspired to the ETSI-ZFM and inspired also to the service-based architecture developed in 3GPP for 5G. We implement strict separation of responsibility and scopes between whatever is per domain and whatever is interdomain. And we use a service bus to implement the interconnections between the different functional elements in order to implement a pattern of publish-subscribe and avoid sticking to single point-to-point APIs. And this will span the full scope of slice lifecycle management, service and resource discovery and management, network analytics, and security and trust. As I said, the platform is distributed across the different operators, so there are distributed instances in all the participating domains, and these domains interact through a trusted data layer, which is based on the DLT technology, and where SLA enforcement, resource discovery, and spectrum management is implemented, and interacts with an operational data lake for AI operations, AI ops. In fact, we intend to run through the 5G operational data lake smart and efficient data collection, intelligent data storage over time, and advanced AI-driven data analytics for valuable and optimized decisions to be taken into the network with respect to the services. The innovative aspects of this architecture can be summarized in three major points. The first one is automatic discovery and inventory of resources. This architecture really allows this with all the benefits I mentioned before. And so we can really count on the fact that compute, storage, network, spectrum, service capabilities are really announced, discovered, and then selected at an upper layer in trusted and secure mode. Second innovative aspect, intelligent third-party resource selection, request, and access, which is composed of an efficient day zero operation, so whatever matters with the instantiation part, where we can instantiate across different administrative domains, both slices and services, and stitch together various type of technologies domains and do functional splitting for the mesh networking, etc. There is also a second part of the orchestration story and lifecycle management story, which is the intelligent day one and day two operations, which means configuration and optimization respectively, where we plan to use AI engines in order to process the monitoring information in the data lake and consequently decide how to optimize the network operations, implement the SLA monitoring across the multiple parties, and respect the SLA targets, and maintain appropriate security, privacy, and trust among the different domains. Third, trust establishment among multiple parties via blockchains. So the way through the smart contracts to establish trust and negotiate and trade resources among telcos and customers, and resource providers, etc. In order to validate this infrastructure and this architectural concept, we are working on three use cases. The first one is about smart contracts for ubiquitous computing and connectivity. It is a typically edge scenario in which we have multiple operators contributing different type of edge resources, some of them trusted executed environment, interconnected through the blockchain, also to the operational data lake and to the service layer of the 5G Zoro. In In this use case, what we aim to demonstrate is the possibility to implement trustless interactions between multiple parties in a permissioned private DLT. And the smart contracts we are defining will cover resources of all kinds of the assets for the edge computing typically, so computing, storage, networking, DNF, CNFs, but also services. So the communication services at edge, which can allow to expand the network where the network is not present yet. So a way to deploy G0Bs, a way to deploy virtualized G0Bs, obviously, to deploy 5G core elements where they are installed in resources which are not under the ownership of the VNF provider and VNF owner. And the smart contracts in this framework operate as a way to link together the business transaction to make this happen, and so remove the paperwork for establishing contracts related to this type of services, and the SLA monitoring part, which takes care of making sure that the KPI targets are met for network and computing, for example, in this case. And in order to interact, let different systems, externals to the blockchain, interact with the blockchain and with the other systems, we will make use of oracles, which are gateways between the blockchain and the external systems, allowing the intercommunications and the implementation of the different actions for automation, security, trust, and the establishment of the different agreements. We are currently focusing on the private permission DLTs, and specifically we are working with R3 Corda blockchain, and we are getting alignment with the Career Business Automation Network, CBAN, which is a newly established initiative for profiling the products which among operators in a blockchain can be traded for connectivity cases and slices and 5G. A second use case is about dynamic spectrum allocation. So focusing on the spectrum sharing part, our aim is to develop, as depicted in the picture, a DLT-based spectrum market for real-time spectrum allocation. The spectrum comes from different operators of different kinds, so cellular spectrum, Wi-Fi spectrum, in the municipality, in the private venue. And the idea is to have a spectrum market into which the different spectrum access rights can be traded and possibly configured. For this, we defined spec tokens, which are non-fungible tokens to grant right to use the spectrum in a given location and for a given duration of time. This is traded among the permissioned 5G Zorro users. And there is a hierarchy of users into this blockchain who have different permissions. The national regulators typically are the ones who are at the top of the hierarchy and can forge spec tokens. Then there is the set of the RAN providers who can allocate the portion of the spec tokens into the radio resources, specifically in their area, depending on the smart contract contents. And then the spectrum consumers, who are the ones who consume the spectrum, so attached devices. On top of this, we are also developing some AI-powered trading agents, which are aimed to track the transactions of the spec tokens and so learn how the spectrum is used and consequently be in the position to optimize the way the selling price are offered in the market and consequently also how the spectrum is overall used, or even to readapt in a proactive way the RAN slice and adjust it in terms of contents in order to still respect the SLAs, reducing the spectrum use or even enlarging under some terms. And for this, we need to get access to a number of metrics of the RAN, which are pushed into the operational data lake I mentioned before. Third and final use case is about Pervasive VCDN services, which is content distribution network, so a media use case, and we aim to establish a secure, autonomously scalable Pervasive VCDN, in which we are able to implement zero-touch resource discovery, third-party resource selection to expand the CDN into new areas not previously covered, security and trust in order to implement a secure and trusted way for negotiating the contract and for establishing the services, monitoring of SLAs, obviously, in order to respect KPIs, typical of the CDN in this case, and also adaptation and readaptation of the slides as we go, as well as DNF licensing in order to guarantee that whatever is instantiated into these slides across the different domains can maintain the license of the elements instantiated and preserve licensing rights. This is a case of merging between telco or typical cases like spectrum sharing and resource sharing and access, and media vertical applications like the CDN, which are used as a further case for demonstrating the architecture. So based on this, the conceptual architecture we proposed can have a number of value propositions that can be summed up into this security and trust, which will allow us to increase the network reliability and service scalability. The zero-touch automation, which can lower the cost of development and automate at the maximum level the maintenance and operation of the networks. The spectrum market based on the Altice is one of the major value propositions, because actually it can really reduce the cost expected for accessing the spectrum in 5G, and the trusted environment, the smart contracts among multiple parties can really unleash the way business can be created in 5G networks, because we have cross sectors, multiple stakeholders, multiple providers of various type of resources. We are at a stage now of finalizing our architectural design and developing the initial prototypes of the 5G Zoro components for the architecture and the use cases. And we aim to validate this into two real live test beds, which are 5G Barcelona and 5Tonic in Madrid at the beginning of next year. Just to conclude, and for you to get more information, the 5G Zoro is a project which counts on 13 organizations, and it's a newly born project in November 2019. And to conclude, just visit our website for major information, and thank you.